So in this video, we'll look at some of the types of questions that you will see for chapter 2. First, let's go over the simple questions. One simple question might be on periodic table. Which of the following is a metal, right? And your choices could be N, Na, Ne, Rn. So look at the periodic table. You know the positions of metals, nonmetals, and metalloids on the periodic table, right? And you will notice that sodium is a metal, the rest are all nonmetals. Another simple question could be, you might be given an element, say for example chlorine, and you might be asked what is the most possible charge on chlorine. And if you remember, we talked about this in one of the videos. Group 1 forms positive 1 charge, group 2 forms positive 2 charge, right? And all the group 7A, right, they form negative 1 charge, right, in ionic compounds, right? So chlorine is in group 7A, so chlorine mostly will have negative 1 charge. These are the simple kind of questions. You could go a little more complicated in terms of questions. You could see a question that looks like this. Silver has 2 isotopes, silver 107, which has a atomic mass of 106.905 and abundance of 51.84%. And another one, silver 109, which will have a certain atomic mass, and what is this atomic mass? Silver, from your periodic table, you know that it is on the periodic table, you will see that it is 107.9 atomic mass units. That's the atomic mass of silver. So remember, weighted average of all isotopes, weighted average mass of all isotopes is equal to atomic mass of the system, or atomic mass of that element. Atomic mass of that element, right? So 107.9 is equal to 106.905 multiplied by 0.5184, and this is because 51.84 divided by 100 because it's percent, plus, I'm just going to make this x, so x multiplied by, we have to get the percent for the second one. How will you get it? You will get it as 100 minus 51.84. That will be the percent abundance of the second isotope, or natural abundance of the second isotope. So which would be, in this case, 100 minus 51.84. that would turn out to be 48.16%. So x multiplied by 48.16%. So 48, since it is percent, it's going to be multiplied by 0.4816. And so you solve for x, and when you solve for x, you will get an answer of 108.97 AMU. So the atomic mass of the second isotope is 108.97 AMU. Sometimes though, you might also come across a situation where you will not be given the element. They might just simply say element X or Y or something. You will be given all these four numbers, in which case you should just simply do a weighted average and calculate the atomic mass of the element. The third kind is where you will have to convert between mass, number of particles, and mole. Remember, you have to keep in mind 1 mole is 6.022 times 10 raised to 23 particles or items, right? Items, particles, number, whatever. And 1 mole is also equal to atomic mass of the substance. 1 mole corresponds to atomic mass of the substance. What does that mean? That means that if you take 1 mole of nitrogen atom, okay, this will have 6.022 times 10 raised to 23 nitrogen atoms, and this sample will have a mass of 14.01 grams. What kind of a question will you see here? How many moles of nitrogen are present in a sample that contains 17.63 grams of nitrogen, just as an example, right? Please note that here the question N is asked. Sometimes they might not say N, they might say N2. It's based on the question, and I will show you both the differences, both the situations. So 17.63 grams of nitrogen, how many moles? Remember in the previous slide we talked about this. 14.01 grams of nitrogen has 1 mole of nitrogen. And where did I get this 14.01 grams from? From periodic table. So grams of nitrogen, calculate to get moles of nitrogen. Now, if the same question is given in a different variation, how many moles of N2 are present in 17.63 grams of N2? Now remember, if you see on the question nitrogen, automatically take it as N2, because remember, nitrogen exists as molecule, right? But if they say atomic nitrogen, or if you see just N instead of N2, then it is slightly different. So what do you do here? 17.63 grams of N2, but remember on the periodic table N 14.01, but if it is N2, then it will be 14.01 multiplied by 2, which will be 28.02. So then you would say 28.02 grams of nitrogen is 1 mole of nitrogen, and then you solve it this way. In this case, the answer is 0.6292 moles. And in this case, in the first case, it is 1.258 moles, 1.258 moles.